Hello everyone, welcome to today's Vitodens 200 B2HA, B2HB Wiring, Control Interface, and Basic Programming for Startup online seminar. My name is Miranda Getling and I'm the Viessmann Academy Manager, and I just wanted to take this opportunity to say thank you for attending today. We appreciate you taking the time out to attend today's seminar. I also wanted to use this opportunity to introduce you to your instructor today. For those that may not know him, is Jay Sheldon. Jay has been with Viessmann for the last 5 years. The first 3 years, he was a member of the Technical Service Department before moving into his current role as the Academy Training Instructor. Jay has a master license and has been in the heating and cooling industry for the past 30 years, including holding job titles as General Manager, Service Manager, and owner of his own company for 14 of those years. And before Jay begins, I do have a few housekeeping items to go over with you. The first is everyone will stay muted throughout the entire seminar. However, about halfway through and at the end of the 2 presentations Jay will be going through today, he will stop and answer any questions submitted. And the way that you submit those questions is through the Q&A button at the bottom of your screen. You can simply click on this, type in your question at any time, and we will get to those periodically throughout today. We are recording today's seminar and we will have it posted within the next 2 weeks or so in the video library, which is on our Viessmann-usacademy.com website. And once you're on that website, there's 2 ways to navigate to that library. The first is up top in the header. You can click on where it says video library, or if you simply scroll down, there is a larger video library section, which you can click into. And once you're in that library, this is what you will see. Up top, we do have that search function, so you can put in keywords to navigate through the library. And then we have a recorded online seminars section in the drop-down bar. And this is where today's seminar will live and all of the other seminars we have done to date. And since this is on the Vitodens 200 specifically, it will also be in that Vitodens 200 B2HX section. This will also be on our YouTube channel, so if you go to youtube.com, type in Viessmann North America, our page will populate and you can see the videos that we have in there as well as today's recording. And with that being said, let's begin. Here is Jay Sheldon.
Thanks, Miranda. Thanks everybody for coming. Welcome to today's class on the 200 boiler. And today we're going to be covering the 200 wiring of the boiler, as well as some programming of the boiler as well. So to get you a little more familiar with these controls if you haven't done them that much. And hopefully you can pick up a couple of neat little things that will help you out throughout the presentation. And please don't hesitate to ask questions. If you came here with an agenda and you have questions, don't hesitate to ask, please. And one person asks a question, everybody gets the answers emailed out to them once all the questions have been answered by me once at the end. So like in a week or so, you'll get the answers, questions and answers sent out to you. So also, I do appreciate you taking your day out because we are getting a little chilly, aren't we, out there? And I know what it's like. My phone's already rang twice today, and I don't even do it anymore. I try not to do it. It's just too hard, but if you think you can get out of this business, think again. So we'll start with the wiring of the boiler. And from there, we'll go on to the programming. And we have exciting news with the boilers as well as servicing. They just came out with a new service kit for these boilers as well. So you look forward to a 1 part number and you'll get a little service kit that has like your basic fitting parts that you may need for your annual maintenance and things to that nature. So that was pretty cool. Not like the one we had, 4 or 5 years ago, or even longer when I bought mine. They were pretty much everything. You could almost rebuild the whole boiler with that control kit and the parts kit that they sent out. So it's not going to be quite like that extensive like it used to be. So I think it will be pretty handy, especially if it's just your electrodes and things like that. And every now and then you're going to replace them anyways, right? All right, so we're going to get started. And like Miranda said, about halfway between each presentation, we'll stop and ask for questions. We'll answer those and then move on. And then at the end of each one, we'll ask questions again. You can all answer questions again. So let's get started. So this is what we're going to talk about today. We're going to talk about your line voltage, your low voltage, your sensor connections. And you're going to find with our boilers, all our boilers, since they've come here to the US, have always been the same numbering, wiring, sensor-wise, as well as where you're going to wire in your voltage and things to that nature. So once you learn our system of wiring, and our sensors are auto-recognized, so as soon as you plug in a domestic sensor or anything like that, it auto-recognizes it. So you'll see as we go along as well as that. We'll talk about your functions of your boiler flow switches and sensors, because on the smaller boilers, they have flow switches. On the much larger boilers, the larger boilers have flow sensors. And we'll talk about how to wire in your low water cutoff. And right prior to that, your flow switches actually have been approved to be your low water cutoff. So if you needed like a piece of paper to show your inspectors, usually the reps have that on file for you, and they can send that out to you. But in some states, they still require, like I'm pretty sure New York City requires a low water cutoff. So we'll go over that as well, where to wire that. And if you're doing multi-boilers, we actually have a multi-boiler low water cutoff box that you can put all your low water cutoffs to one box. So if you haven't seen that yet, we actually have that as well. And we're going to be talking about the B2HA and the B2HB today. The differences on the HA model, that was the original model that first came out. The first generation would be called an A. The second generation would be called a B. But there are some differences between the HA and HB. If you didn't know, the HB is more, I would say, more for residential uses, and then the HAs are more for commercial uses. At one point, they had to become 95% efficient, so that's where they kind of made the separation as far as that goes. For residential, you had to meet the 95% to get the efficiency rating, as well as the rebates that are out there. So if you've never worked on the boiler, I'm sorry, I always like to point out that on the 200 especially, we tend to hide the screws on the cover. So normally to get the cover off the boiler, you have to remove that bottom skirt. It just slides straight out towards you. And then you'll have to look up inside here on the right and left-hand side of the boiler here. They're recessed up there. So you have to actually look up inside this piece of plastic, and then you'll see the screws. And then you'll just loosen them up. You'll feel them drop, and then you'll stop. The plastic holds them up in there so you don't lose them. Then you'll be able to lift up the cover and then slide it out towards you. On the cover below, once you get the cover off the boiler, down below there's a box. And normally there's going to be 2 screws in the front of this here with a cover on it, and then 2 screws on the side, and it allows you to pull it out and let it slide down so you can work on all your wiring. Let's go over our wiring once we fold that cover down. As you can see, this is exactly what you would be looking at right at that control box when you folded it down. So on the right-hand side is mostly where all your line voltage is going to go, your pump outputs, your incoming power, things to that nature. And then, excuse me, on the other side, you'll see as it's going to be your lower voltage or your communication to the boiler. So with the 200, you do have to wire in the pump underneath the boiler, and it always goes on the right-hand side of the boiler, pumping into the boiler. That's the way we activate that flow switch or the flow sensors. So if you put it on the supply, sometimes it may work, but most of the time it does not work. So always your pump goes on the right-hand side of the boiler, facing it, pumping up into the return side of the boiler. The 21 pump is always designated as your domestic pump or going over to an indirect. But in coding, you can change that to be a heating pump as well. Same with 2820 pump output. That can be it's programmed to be a recirculation pump for your domestic side. So if you're doing any recirculation in the house, or say you got a large house and they want to do recirculation, you can do your pump right to here. You can go out and buy. You don't have to buy like the expensive pumps with the push pins with the timers on it. There's a time program on this boiler that will actually do domestic recirculation. Your multi-plug, that's where they recommend where you would put the low water cutoff. You can put it there, or you can put it at your 40 plug, which is always going to be your incoming power here. So you could wire it to your low water cutoff and then come into the boiler and power your boiler through your low water cutoff. If you do use the multi-plug, you do remove the jumper up, and then it's power up and power back down to the multi-plug. On the EA1 module, which is on the other side, and by the way, you can buy added one of these here, so you could add more modules and more outputs to your boiler as well. But your DE1, DE2, and DE3 are your end switches or your thermostat placements. 0 to 10 output. I'm sorry, input rather. Your input is here for 0 to 10. So if you're doing TECMAR or anything like that, and you want to take a 0 to 10 input to the boiler, you can do it that way. In Europe, they have thermostats that give 0 to 10 as well. Then the 145 communication here on the far left-hand side. This is where you would end if you say you were using our three-way mixing valve for a radiant or anything like that. You would just send the 145 communication over to the boiler. It now knows that you have our mixing valve connected to the boiler. So remember, auto recognize on most of our sensors as well. That our mixing valve comes with its own outlet temperature sensor that goes into a box that you plug into the wall, as well as your circulator goes into that as well. I like our three-way mixing valves. I've had very good luck with them with their boilers. I've had one in, just for an example, in my house for 22 years now, and still going strong, knock on wood. But any communication, if you're using like the Vitodens room thermostat to control the boiler as well, that 145 communication would go over here as well. You can daisy chain from one mixing valve to the next, and then it would see all those, and you could set room temperature set points as well as heating curves for each one of those circuits that you hook on. Over here, you see the 157. That can be an alarm output. Or a pump output. And when you're doing the startup wizard, usually it's going to ask you to, if you want to use our pump relays in our boiler, it's going to ask you to pick either the 2820 pump output or the 157 pump output. If you're going to use the 157 pump output for a pump, you have to bring power from your 40A and power that one side of that relay switch. It's all in the instructions as well. But you're going to take power from that 40A, bring it over to the 157, so when that relay closes, it powers your circulator. The top control holds your interface and where you're going to program everything. There's two little ears on the side, left and right here. They fold down, and then that allows you to fold down the main control. Your interface is normally here in this empty spot here. If you don't pull that bottom apron off, it won't allow you to fold that out, but you don't have to pull it out all the way. You can just slide it out a little bit so it allows it to fold down. And that's that little apron at the bottom if you decided just to look at it and not pull the apron off. On the left and right and the back side of the control cover, where you were going to do like your outdoor sensor and all of that, you'll see coming up. You may need a little screwdriver. I know nowadays that now I'm not so much out in the field anymore. I actually have a little bit of fingernails here, so I can pry that open. You just stick it right under here, or a small screwdriver. You pop them out on left and right. Once you do that, then it allows you to reach in the back and take the ones off the back and lift those ones up as well. Once you do have the cover off, this is what you're looking at here. So now you can see all the different things like a coding card or this orange plug here in the back. You can actually pull it out, then hook your number one, which is your outdoor temperature sensor in there, as well as if you want to do your low loss header sensor. And most of the time you're going to do primary, secondary with this boiler. So you can put your number 2 sensor right here and on that same plug. Called the X3 plug. There is a spare fuse on the boiler here, so when you slide this piece of plastic out, you'll see in the center of that plastic, there's a spare fuse in case you happen to let the smoke out of the box. On the far left here, you'll see that this is where your lawn card's going to go. This one actually is showing Viessmann's KMK card, which if you weren't doing building management, but you still wanted to do multiple boilers to communicate with each other without doing building management, you could use the KMK card, but pretty much all of them now are coming with the lawn card now. So now you can see where your sensors is. It's just a better picture of what we were just looking at here. And then we have a 0 to 10 output. So I was playing around with this in the shop actually. So now they have 0 to 10 pumps. So you can actually control a pump with 0 to 10. I was messing around with that. I haven't quite finished just to see. It's kind of difficult in our office to see how things are heating because we only have a fan coil. Your outdoor sensor, I always like to mention this because being a former tech support person, believe it or not, this was a common problem, location of your outdoor sensor. It is a 10,000K NTC resistor inside here, and we do have charts in the manual. I actually have troubleshooting on these as well if you go into the videos. But we want to see our outdoor sensor on the northwest side, the coldest side of the building. Don't want to see them under a dry vent, which is kind of common, and exhaust vents that we just drilled out that new hole so we can get our thermostat wire out there as well, and then hang our outdoor sensor right under the exhaust. So we want to make sure we're away from any exhaust, any sunlight to fool it into thinking that it's warmer than it actually is outside. So you'll get the calls, and it can be a headache if it's located in the wrong side if you're going to do outdoor reset. Low loss header sensor, if you're going to use it and put it in the low loss header, it's just going to go onto that same 3 and 4 X3 plug on 4 and 5 terminals. And that's also a 10,000K NTC resistor. It's pretty neat the way this works. It's always maintaining a certain temperature right here in your low loss header, or even if you were using like a buffer tank. I know a lot of guys in like Alaska, they use buffer tanks for their radiant. So you can use that same thing as a low loss header. And the nice thing is it's always maintaining the right temperature here. With our smaller ones for the smaller boilers, it's always in the flow going out to your system to check the temperature going out to make sure that you're getting the most accurate temperatures going out to your system. Same with our domestic on the boiler itself. When you take the cover off, if you look on the left-hand side of the boiler, you'll see these 2 little red tabs that say number 5 on it, because our number 5 sensor has always been our domestic sensor. So all you're going to do is plug that number 5 sensor right in the 2 plugs on there. And a lot of times it's hidden behind the pipe on the boiler here. And so they're there. So as you can see over here, there's a number 5 on the plug itself on your sensor, as well as when you look on these 2 little red tabs on the boilers, it will say number 5 as well. And you're just going to plug that in, and remember it's auto recognized. So as soon as you plug it in, it now knows you have domestic hooked to the boiler. The only thing I always like to say about that is just be aware of, let me go back here a couple. If you're doing a low loss header or no low loss, or doing a low loss header and your domestic is on this side, your primary side, your boiler side of it, it's set up that way in programming. If you find that your domestic's on the other side of your low loss header on your system side, if you have a header or something that is coming off of, you have to go into programming. I believe it's 5B in domestic, and that you now have to tell it it's on the other side of the low loss header. Because remember, we have a pump underneath that boiler. As you can see here, here's our boiler pump, that our primary pump underneath our boiler, which goes through and activates our flow switch and pumps the water out. And if you look in our drawings, this is the way they want to see our domestic tank going over to our indirect on the, this is showing it on the boiler side now. They want it above that primary pump, because what happens when it's on the primary side, what happens is that pump will shut down and allow the domestic pump to come on. So you don't want it on this side deadheading into a dead pump. And also so it does kill the power. So if you are on this side, say you got these two here going out to your indirect tank, you now have to tell your boiler through coding 5B and domestic that you're on this side of your low loss header. It's pretty simple to do. You'll see once we get into coding as well. This is just showing where you might put all your sensors or your outputs, like your pump outputs. So remember that 2820 can be either domestic recirculation, which we have a recirculation tapping on all our indirect tanks for recirc. You can put one there as well, or you can make it a system pump. Here's our plug numbering system. So you'll see in the red, mostly all our line voltage outputs or inputs. And then in the blue, you'll see that mostly all our low voltage or sensors. Remember, the sensors are auto recognized. So as soon as you attach it to the boiler, it now knows it has that. So our outdoor sensor, 2 sensor or 5 sensor, if once you plug those in, it knows it has something connected to it. You do have to have the outdoor sensor connected to the boiler, whether you use it or not. You have to have it tied into this boiler, whether you put it outside or not. Still has to be connected. So a lot of times I used to tell guys to hook the outdoor sensor, put it on a small piece of wire and throw it in the cabinet or somewhere where, and then make sure you adjust your outdoor temperature settings so it doesn't come on. Your Z1, your Z2, your Z3. So these could be end switches. These could be thermostats coming right to the boiler. Remember, they have to have a no voltage on either an end switch or your, they have to be contact free, voltage free, sorry. So these are on the, remember that control that we're gonna fold down. So say you're doing multiple zone controls, you could have 3 different multiple zone controls tied to this boiler, depending on, you know, how many BTUs boiler you're using, and have multiple zones. So you could have a TACO or somebody's 7 zone control with an end switch coming over to the boiler here, and then another one tied to zone 2, and you could make one a fixed set point, and then you can make the other one outdoor weather responsive. So you can do a multiple different things with this, as well as with your, if you're using mixing valves, you can do their own heating curves to them as well. So you can have heating circuits as well as zone circuits with this boiler. If you don't know about our heating circuits were more or less back in the day, like I have in my house. I have no thermostats in my house, so I do a constant circulation in my house, and it modulates to the outdoor temperature with a room temperature set point that I do off the control of the boiler. So like I was saying, you could either run your thermostats directly to the boiler and have our boiler control your pumps. So in this case here, we have 2 thermostats going over to the boiler, and we're controlling the 2 pumps going to the systems. As well as we're doing our boiler pump, as well as we're doing our domestic pump. Excuse me. So if you have a 2-zone house, the boiler will handle it. You don't have to go out and do relays or anything like that. You'll have that right in the boiler itself, as well as your domestic tie-in for your domestic pump and your primary pump. Just showing your pump output. So when we go through this, you'll see it'll make more sense when we go through the startup wizard. It'll ask you to pick a pump output like your 2820 or your 157 pump output. That when you're done, it will say give you a summary of what pumps you picked and where you're going to wire them to. but you can actually go into your coding and change it as well. Say you don't want it to be a recirculation pump, you want it to be a heating pump. You can go in there and change it just by going into coding. So after you've done the startup with it and you change, you want to go back in there, you can change it. You can either start up the startup with it over again, or go into coding and change it to one of these three. So at the bottom here, I kind of just gave you a little quick wiring thing here with a marker here I just put on there, just so you can get an idea of that 157 pump output that they asked you to pick through your startup wizard. So now you can see you're going to go from L over to P to power this relay. And once that relay, the contact is called in by your pump output, or your thermostat or your relay, it now powers up O over to the pump, and now your pump will be energized. But you can also change this to do different functions as well. Normally, when you do come in for wiring the boilers, I disconnect all the wiring on the boiler, and you guys come in and you wire in all the boilers. So I just take pictures of before and after. So this is what you're going to look at when you get in and come to wire the boilers. Kind of put a little piece of tape just to let you know that this is your main power. This is going to be for your pump output, and this is going to be like your 20 output. So now you can see how the wires actually go. And for years, I was always wondering, you know, what these little loops were, but that's how you wire in your wire. Just hold it, kind of makes it look neater. But your 40 plug is going to be your incoming power, and that 20 pump, remember, it's going to be that pump underneath the boiler to activate your flow switch. That's always going to be on your 20 pump. On the newer pumps, boilers coming out, some of the smaller boilers are going to be like our 100s and have the pump built in. So that's going to be one less thing you're going to have to do in the near future. Now we're showing you running 3 zones here. But now you're going to add that AM1 module. So the AM1 module is going to allow you to add more zone control. So if you need more thermostats at location and more pump outputs, you can get our AM1 module. But remember, you can do the same thing with a Takeo board or whoever's. I just use Takeo because they're right down the street from us here. I've used everybody's, believe me. Anyways, you can get either our AM1 module, which allows you to do 3 more circulators, or you can get a multiple zone that does, you know, as many as needed. This is what it looks like here. It's a box. You just plug it into the wall. Mixing valve, as you'll see, is pretty much the same type of box, just a different kind of setup here. But now you can see you can add more pumps, and now you're just going to send that 145 communication to remember where down at the bottom of the control. That 145 goes from here to that 145 communication. We now know that we have an AM1 module hooked to the boiler, auto recognized. So we're about the halfway point of the wiring. Hopefully I'm not boring you and putting you to sleep, but hey, if you have any questions, remember.
All right, looks like we don't have any questions at this point, Jay, if you'd like to move on.
All right, awesome. Don't forget, if you've got questions, ask them. I don't take points off for any questions at all for the test at the end of this. All right, so now they're showing you what else you can do here. So like if you weren't getting our AM1 module, you could do something like this to control. This one here happens to be controlling zone valves, as you can see here. So we have multiple zones going, controlling your primary pump going out to your system. And then all your zone valves would actually get wired up into your zone control as well. and then your end switch or the XX goes over to DE1, DE2, or DE3. Remember, you can have multiples of this. You can have one doing a fixed set point, and you can have one group doing modulation to the outdoor temperature. So you can do 3 different temperatures out of this boiler and a fixed set point. The neat thing with 200, I recommend doing outdoor modulation, even if you're doing hydrocoils or heat coils or things to that nature, because you can put a minimum and a maximum on our heating curves through coating. So it won't allow it to drop down. Say you're doing a heating curve and you don't want to go below, say, 140. You can say, okay, I don't want to go below 140. I don't want to go over 160, whatever. So you can still modulate to the outdoor temperature, but you're not going to go down so low that that's going to blow cold air. Now this one's just showing you a different zone control using pumps. Same thing, you're going to send just the end switch over to the boiler to DE1 or DE2, whatever one. And like you could have the prior picture was a Takeo. This one here, you could have 2 of these in there and have 2 different end switches controlling these systems. It's always going to go to the hottest temperatures first if you're looking to know that. So hopefully if you're doing any type of mixing, you have some, like for radiant, you're going to have some type of mixing valve as well. So now with the Viessmann's mixing valves, it comes, like I said, with a box, just like that AM1 module. It also comes with a boiler supply sensor. I'm sorry, a piping supply sensor, and a place to land your pump, as well as power your 3-way mixing valve. And then all you're sending over from your 3-way mixing valve box is that 145 communication over to 145 on the boiler. Or if you had multiples like this, you could take it from this 145 to this spare 145, and out of this one over to the boiler. It now knows it has 2 mixing valves tied to the boiler. Just remember, if you are doing HC circuits, and HC1 is always going to be for your highest temperatures. It's going to be a fixed temperature for the highest temperature. These are going to be your mixed temperatures, HC2 and HC3. And if you're receiving a 0 to 10 input from these types of things, this is where you're going to tie in your 0 to 10. And with ours here, 0 to 10, it usually shows it in voltage, but for each 1 volt is, I think, 10 degrees, as you can see here. It is polarity sensitive as well, so you're going to have your plus to plus, minus to minus, or red to red, blue to blue, whatever color you're using. Just showing you our sensors here, just to show you that they are all numbered as well. So all our plugs, all our sensors are all numbered to make it easier for troubleshooting as well as replacement. It also gives you the temperatures that they will operate to. So our adjustable high limit, which is going to be that number 3 here, our number 3 sensor, is a range from 68 to 180. And remember, if you're using your outdoor sensor, we have boiler protection. So cold weather protection. So on this boiler here, as soon as it hits 32 degrees outside, it maintains 68 degrees on the boiler. Maximum temperature with our smaller 200s is 180 degrees. A fixed high limit goes off at 210. With our larger boilers from the 399, from the 160 to the 352 have two number 3 sensors, and they bounce off of each other. So if they drift about, a half a degree or 2 degrees from each other, I'm sorry, 2 degrees from each other, you will get a fault. So if they do any type of drifting from sensor to sensor, you will get a fault between the two. They're both 10,000 K NTC resistors as well. And these are on your larger boilers as well. Your 399 and your 530 models. So these wall hungs get pretty big at a 530,000 BTUs. On the smaller ones, excuse me, we have a flow switch. The flow switch is activated by your pump. So now you can see that the water comes through the boiler, comes down and goes down. So your actual arrow on these things are pointing towards the back. There's an arrow on the top and you can see it once you have it out. And I always tell people, if you're ever taking a look at these, make sure that that wire is coming out towards the pipe, the brown wire, and then that will ensure that you know that this is going in the right direction. You can check these with, it's just an open and close switch. Or if you want to see if your boiler is activating, if there's not going for some reason, you think everything's working right, you can jump out the plug going to the flow switch, the boiler should fire. And then you know that you're having an issue with your flow switch. And sometimes it could be just a matter of something's got stuck under the paddle, like a solder ball. On the larger boilers, your 399 and your 530s, you have ultrasonic flow sensors. Remember, the smaller ones have the paddles. Your larger ones have ultrasonic flow sensors. So the same thing, if they drift off about 2 degrees, you'll get a fault as well. And they're always constantly checking each other for flow. A flue temperature sensor, also a 10,000 K resistor. And as you can see, it goes off around 230 degrees. And typically our flue gas is normally anywhere from 4 to 27 degrees hotter than our boiler return water. So our flue gases are typically 4 to 27 degrees hotter than our boiler return water. So just to, I have guys, they send me pictures all the time. So I put them up here just so you can see what an installation looks like with this boiler here. Some guys pipe it in. I don't know, this guy might have had stock in Taco. But nice looking job. Now you can see a couple multiple zones system set up here. That's why I like this one here. So now you can see we have 2 different zone controls here. We have our 3-way mixing valve here. So they're doing radiant as well. Here's your radiant block over here, as well as an indirect storage tank over here with recirculation. So you kind of can see everything on this setup here, as well as they did do a low loss header here. It's a nice way of piping our low loss header where you can see the feed valves coming in the top. We got a high junior spiral vent up there, and that's pretty much all the air elimination I ever use is right off our low loss header as well. I just usually use somebody else's spiral vent because or a high vent rather. We give you a bleeder key for the very top there, so you bleed it a couple of times. But it's a very good air eliminator because this is designed so when the water flow is coming in, it forces the water down and allows the air to flow up. So it works really well. As well as at the bottom, they always recommend putting a boiler drain here at the bottom to flush that out because it collects all the mud and sludge inside the system. And so during your annual maintenance, this might be something you might want to take a look at and flush that mud out. The neat thing with that is it doesn't stay there. If it gets full, it just keeps getting circulated through the system until you can flush it out. So that was just a little quick presentation of wiring and low voltage where the sensors go. Just remember things that where you can switch pumps from primary to pumps to secondary for your domestic. Things to that, as well as your flow switches. Remember, they have flow switches and flow sensors. If you're cleaning the flow sensors, you don't want to poke it or anything like that because it is a sensor. Just wipe it off. If it's off, I would just replace it. to go through all that trouble and get into the back of the boiler and get to those flow sensors in the back just to clean them. I would think it would be better to replace them myself. And if you're going to do that, little helpful hints is I would take the burner out and get that stuff out of your way. It's only 6 bolts. It comes off pretty easy. And you can see that through our maintenance of the boilers itself. We're at the end of this part of the presentation.
And just a reminder, if you came in late, the Q&A button should be at the bottom of your screen, which is where you can type in any questions you have throughout the entire seminar today.
And even if you think of them after, at the end, Miranda will post the Viessmann Academy email address. And if you think of them after the training, it's like, oh, Don, I should have asked them that question or whatever it may be. You can always send it into there as well.
Yes, and we'll send out a copy of a PDF of this presentation, and then of course the Q&A document, which will have all of those questions and associated answers in there. Looks like there's no questions right now, Jay, so you can continue on to the next one.
All right, so now we're just going to go into the basic programming of the control itself. And these controls have come a long way, and then they're coming even farther with the next generation. So I'm pretty excited about the next generation as well. So when I first started doing these boilers, it was a process to program them. And a lot of times it was just in German, so it made it even more difficult. So on this one here, we're going to go over your HO1B, which is that interface that you're looking at in the front of the control. The symbols, what they mean. I always like to go over the importance of the time and date with this control. As well as we'll talk about the startup wizard and temperatures, either doing a mix or a fixed set point. And how our heating curves work and where you might want to start adjusting them. All right, so let's get started. So that is the HO1B interface control. And as if you done multiple boilers of this used to be our cascade control interface as well. Now that has turned into more of a touch screen. So if you're doing multiple boilers, you'll see a different image than this touch screen here. Excuse me. If you haven't worked on this boiler before, and believe it or not, I have had these calls, where is your on and off button for this boiler? You have to slide these little doors here, left and right, to the sides. On the left-hand side is your reset button, your pressure gauge, and then your OptiLinks here, where this V here, we actually sell a device that you can plug into the V where the homeowner can have some type of monitoring of their boiler, where whether it be a fault, they get a notification, or if they want to do temperature changes, or say they want to do vacation mode, you'll see, we'll go talk about that as well coming up. Red, if it's just blinking red there, you have a fault. Green's all good. We're on the way. The new control interface, I like talking about that because as an owner of my own business for quite some time, the biggest issue I had was getting help and training help and trying to get everybody on the same page the way I like to do it. So the new control, what it's going to be is that V that they have for the homeowners now is going to be for the contractor as well. So the contractor will be able to see the location of the customer. So it'll be a push pin on a map. You'll see all your customers that have our boiler control. It will be a red, green, or yellow push pin color on that map. Green means that boiler's running properly, you're good to go. Yellow, you put in that you want the annual service to come up to your phone, so you can now contact Mrs. Jones or Mr. Jones and say, hey, your 2,000 hours or whatever you programmed in there to come up, you're now up for your annual maintenance. If you have a red thing, it's going to call and give you a sign that there's a fault on this boiler. It's going to tell you what the fault is, and then it's going to tell you what parts to bring with you. So I think that's really neat on helping us train newer people coming into the market because we're getting less and less. So as you know, we're always running around trying to train people to do this and that. So this might help if they know what pot to bring with them and how to fix it and what they need to do before they even get there. I think that's a really nice, helpful tool coming out. So let's talk about the navigation of the keypad itself. Start with the very top that I always call it a U pointing left. That's your return to the previous menu. Your navigation buttons are up, down, left, right. And then anytime you make any type of programming change or any type of change and you want to store it, make sure you hit that OK to save it or acknowledge it. So or you can acknowledge a fault or you can save your information with that OK button. The help menu is that question button. So if say you're looking at a screen and you don't understand what they're trying to say there, it'll give you a brief explanation on most things of what you're looking at. And then your menu key is going to bring you to all the different sub-menus. So like I was saying, prior to the startup wizard coming out, this is the way you would get the boiler. You would get it in German. And you would have to do all of this changing once you got the boiler. So it came in Celsius, and you know, we are the only country that does Fahrenheit. I get that, but whatever they made, we got here. And so you would have to go in there and change it. So if you didn't understand German, that's boiler temperature there. So what we're looking at, so we want to, it says to go into and look for this word here. And my extent of German is watching Hogan's Heroes. So Einstellagen, I have to ask, I'm not even sure if I pronounce it correctly, but I always told guys on the phone, scroll down, hit your menu button and scroll down till you see the gears. Once you see the gears on the right-hand side, that's now telling you you're in settings. Once you hit OK, language comes up, and then we will look for whatever language you want to put in there. The neat thing with the older boilers, it had a lot of different languages. So if I had customers that spoke different language, I could actually put their language in there and they could kind of follow along with me while I was explaining the boiler to them. So, you know, it was good in a way. So you would put American English, check that off. And then once you do that, you hit OK. But if you have to go back and change anything, you're going to hit that menu button at the very bottom of the the controller, and then scroll down to settings. So now you can see where that settings is, which means those gears. And now you can see, once you do that, you can see your time and date, your language, your contrast, your brightness, your temperature of unit. And that's where you would change from Fahrenheit to Celsius, was on that temperature unit. So this was the original way of when this first control first came out 3 or 4 years ago. So I always like to show this because if you do have any of these older boilers out there, you still have to go through that when you change the control, unless you update it to the new startup wizard, which is a little more involved than just changing the control. You have to change the control, the interface, as well as the coding card. So I'm not sure if people want to go through that expense of doing that, but it does create a whole different boiler by doing that. The other things that you would see, so temperature units where you change your Fahrenheit to Celsius. You can actually name your heating circuits if you wanted, if you're doing heating circuits. Like I have one first floor, one second floor bedroom. So you can name them different names for your heating circuit. So if the guy's looking to check what that system is doing, it kind of helps him out. Oops, sorry. So just showing you here, when you go into settings, now you can change this, your temperature units from Celsius to Fahrenheit and then on. And so now you can see everything's now in Fahrenheit, as well as now this one here showing you a heating circuit here. So with heating circuits, it's showing you inside the house, that's your room temperature set point. So like in my house, I would go down to my boiler, and if I want my house to maintain 70 degrees, I would put 70 degrees here. And now this is showing me what my outdoor temperature is going on here. time and date. I always like to talk about the time and date and why it's important to put the time and date with this boiler. This boiler here, time and date, I find to be very essential for if you're doing time programs, domestic recirculation, on and off. You can do on and off for your domestic as well as you can do on and off with your heat program. So you can have a heating time program, a domestic time program. If you're doing heating and time for your domestic, you can leave it in automatic. You'll see when you go to set a time program for your domestic, if you just click automatic, it will automatically follow that heat time program. You want to do a separate domestic, you'll put it in individual, and you'll have an individual time program for your heating and an individual time program for your domestic. But more importantly, our fault codes come with time and date on it as well. So troubleshooting, it helps a lot. Just for an example, I always tell this one here because it had happened. And we were able to find it through time and date on the fault. It was a new installation, and a person hired a different company to install a generator. The generator was installed without updating the gas piping or increasing the gas piping. So the guy programmed it to come on and cycle every Wednesday to test itself and come on. So we happened to look at the fault code, and then we saw that that fault was coming in every Wednesday at 7 a.m. in the morning for when that generator cycled itself. It was actually sucking the gas out of the boiler. So that's why, to me, with time and date is important. So you can actually sometimes troubleshoot with that as well. As I had one when I was younger, and I was a manager of a company, we had replaced everything on the boiler. And by the time the manager gets out of work and heads over to this place, it was about 7 o'clock at night. And I had bought this winter watchman thing, which you tie into the boiler, and it will give you your temperatures when it shuts off, voltage and all of that things. And as I'm tying this in at 7, the lights dimmed in the house. And I turned to the customer, I'm like, does this happen? He's like, yep, every night at 7 o'clock. So that would have helped me figure this out as well, because we could see that the boiler won't fire at 70 volts. And so that, to me, that's why it's important to put your time and dates. As well as if the homeowner wants to play around with their phones and things, to put time programs in, or vacation mode, which they call it holiday mode in this boiler. So holiday in Germany is vacation. So if you're going, say you have even if you had a vacation home and you want the boiler to come on before you get there, you can program it that way. Excuse me, program it that way, and then have it go off when you leave, or vice versa. You go on vacation, you have your boiler go into a reduced mode or off mode, and then when you come back, it's already on and running up the temperature. So things like that you can actually do. As like, I used to do it in like a church for different days of the week. They are on, they're off, they need the heat, they don't need the heat. So you can do a time program as well. And it works really well. It's like a setback thermostat, except we're not with a setback thermostat. What you do once it comes to that time at night, say you want it to drop down at 10 o'clock to lower temperatures, the thermostat just shuts off, right? It just kills power, you're done. With doing reduced modulation, it slowly reduced the temperature of the boiler to reduce down. So you never lose that cycle time. Like when people go to work, they turn the thermostat down to 64 degrees. And then when they get home, they want it to come up to 70 degrees. We know how that works, right? So with doing it reduced temperature wise, you're not going to get that frozen pipe, less likely. So when we hit that menu button, then this menu comes up, and then we click on the heating menu. This is the sub menu that will come up when you hit on that heating menu. The heating menu, it comes up with this: the party mode, the economy mode, room temperature set point, the red room temperature set point, operation program, as you can see, goes down. So let's cover a few of these. Party mode, as we know, Germans like to drink a lot of beer, but that's not what it means. Party mode is if you're doing, say, a reduced temperature mode on our boiler. So at night you want it to go down to 64 degrees. What this allows you to do is go down, hit the party mode, click OK on that. and it allows the boiler to run its normal operation for 8 hours, and then it reverts back to that reduced mode. The economy mode's the exact opposite. Say you're leaving and you want it to go into reduce mode for 8 hours, you can hit that economy mode. You hit that, and then it will automatically reduce the temperatures, either being your domestic or your heating. Room temperature set point, remember that's if you're doing your heating circuits that way, you would set the temperature of your room temperature set point there, as well as you can do it on the main screen. Remember in the house, so we saw that 70 with the arrows up and down. Or you can come to the your heating menu and do it here. And I was jokingly earlier saying the red room, what that stands for is the reduced temperature. So reduced room temperature set point. So normal operating temperature would be, you'll see a sun for your daytime operation. And then reduce turns to a moon. And then you'll see a moon on your screen and know that you're in a reduced mode program. So I always like to joke around red room. But that's reduced temperature there. And as you can see, you can go from with heating and domestic or domestic only. I do have some caterings with our boilers in it, and it's only in domestic. Just remember, if you're doing only domestic, doesn't mean you can't have no outdoor sensor. You still have to have the outdoor sensor to the boiler. Whether on that, some situations, I hung it on the wall, knowing that it's not going to get warm enough, but I play around with my room temperature set point, so I know the boiler's not going to fire for a heating curve. Heating time program. So if you click on that, that's where you would go to your heat time program. And with the original boiler, you actually had to go in there and take the heat time program out because it was set up from, I think it was 600 to 1200 hours. So that means that boiler would shut down after 12 a.m. and it wouldn't come back on until 6 a.m. if you were running a room temperature set point. So you had to go in there and put it from into a 24-hour time clock. Holiday program, that's where you're going to click on that, and that's where you're going to put your leaving, I'm coming home type of deal. And then if you want to make any adjustments on your heating curve, you're going to go here and adjust your heating curve, which we'll talk about more down. So with our boiler, it comes with a slope and a shift. Just be aware that all our boilers are defaulted at the 1.4, as well as our fixed set points pretty close to that as well, because in Germany law is that they cannot exceed 167 degrees. So that's why our boilers do come defaulted at about the 1.4 heating curve. So if you want a warmer heating curve, you can adjust it there. And then the shift, we're going to talk about that now. We're going to talk about heating curves and slopes and shifts. So the neat thing with our heating curves, while you're adjusting them, you can see your actual temperatures change. So the slope is going to do mostly here, how fast you're going to go to your hotter temperatures at the top. So as you can see, as you're looking at this here at -4 degrees, we go up there about 171 degrees. But once it hits -4 degrees outside, we'll be heating that house with 171. So that's where you're going to make sure that on the coldest day of the year, that's the way I always set up my heating curves, set it to that highest temperature. So as soon as you say in this area, coldest day might be -4 maybe. If that, or even here at 14, if you want that 180 here, then you're going to play around with your slope. Shift is a little different. As you can see, it says okay. So when I used to ask people what their shift was, they would say it's okay, including myself. But what that okay actually really stands for is 0 Kelvin, 0 Kelvin. So it's a temperature. So that's doing the bottom end of your scale. Remember with our room temperature set point, if you have it say set at 68 degrees, our warm weather shutdown would be 70 degrees outside. So in a lot of cases, like I always use my mom as an example at 87, her thermostat set at 87. as well as if we went into warm weather shutdown at that temperature there, I would definitely get a phone call saying that she's too cold. So you can raise and lower the bottom end of the scale as well. So your warm weather shutdown is higher, as well as you're going to have hotter temperatures down at the lower end of the scale as well. So you're kind of flattening out your curve, basically. So you're not going to have that nice arching curve that you normally want to see to get these boilers on condensing. Because we want our return water temperature coming back to any condensing boiler below 140, right? So we need to be creative and how to strip all that heat out of the boiler before it reaches the boiler, and our return temperatures are down below, 140. So we're condensing. That's how we make these boilers go up to the 95, 97% efficiency. So outdoor reset, why do we want to use it? In my cases, I like to do a lot of constant circulation, even with baseboard, because that's going to give you a much constant, more even heat space. So with baseboard, you always see you get a fluctuation. It's cold, it's hot, it shoots up to that 180, comes back down. We've all been programmed here especially here on the East Coast, for 180 when it's 0 outside. If you look at anybody's baseboard board that produces baseboard and look at their heat calculations, they go down as low as 118 degrees. Yeah, you're going to have more baseboard in the house, but you're going to do it with lower energy, and that's how we're going to get these boilers to condense. So it's important to do a heat loss calculation. And what I found in these areas, there was way too much emitters in the house. And a lot of times there was one room that was way overheated. And then by the time the temperature got to the last room, there was no more temperature. So it's important to do a heat loss when you're doing this type of things. And to me, it's more important to keep up than catch up. You get those calls and they're starting to come in, hey, my house is not heating up all the way now. Well, how much emitters do you have in the house, or is your emitters blocked? It was kind of funny. I was talking about this the other day as I walked in the door, and I have a nice rental radiator and there was coats covering it. And people were asking why that area wasn't warm. So I wanted to take a picture and say, this is a perfect example of why you get these phone calls in the middle of winter, because they turn their thermostat down to 60 when they go to work and then expect it to get to 70 within seconds when they get to the house. And now we're playing catch up, right? So you're going to burn way more energy than to leave that thermostat. So I used to tell my customers, hey, once it turns 30 outside, leave your thermostats alone. Don't touch them. Because you're going to burn more fuel by trying to keep it down and then trying to raise it. By the time you get up to that temperature, you just, all that energy you thought you saved by turning it down, it's just gone right out the window. Makes the boilers more efficient. So that also, remember, we want the boilers to condense. So if we can run lower temperatures, we can get that boiler to condense. Longer run times, to me, gives you a much more even temperature throughout and lower standby loss. And what do we need to know to set the heating curves? So we need to know what the design parameters you want to have. What are your emitters that you have in your house? What's the construction of the building made out of? And more importantly, what's the customer's needs? We know in offices, I've worked in offices before, there's people that like it cold and there's people that like it hot. But they were constantly fighting over the thermostat. One wanted to turn it up, one wanted to turn it down. So I put 2 dummy thermostats and put the thermostat up in the ceiling. That handled that problem. But as we know, we need to know what they are living in the house. So sometimes you're going to have elderly that feel colder. As they get older, their skin starts to dry and they don't sense the heat as well. Or we have younger people that are like it cooler. Depending on who's living in the house, everybody's different. So we want to know how to set those heating curves according to their comfort level, basically. So here's a heating curve chart right out of the manual. So as you can see, the boiler supply water is on the left-hand side there. your outdoor temperatures down at the bottom. So when you're looking at this, just be aware that they do have Fahrenheit and Celsius on there. So when you're following a chart. So for an example, just to show you how heating curves work and how our heating curves work, we're going to do a 1.0 heating curve today. Just for an example. So what's a 1.0 heating curve mean? So what that means on our boiler means that when temperature drops 1 degree outside, our boiler water temperature will now come up 1 degree. If you had a 2.0 heating curve, 1 degree drop outside, now our boiler water temperature now comes up 2 degrees. So each time it drops, our boiler modulates up and down that way. But you're also going to modulate up and down the scale according to the outdoor temperature. So for this example, we just circled a couple of different temperatures of the outdoor temperature. So just for an example, for this heating system, or it could be radiant as well, for a -4 day, we go up and follow that up to a 1.0, follow that line over through the chart. We're going to be heating that house up with about 140 degree water temperature that day. Once the temperature starts to rise up outside, and as we modulate up and down that scale, it now hit 23 degrees outside. We follow that up to the scale, follow over, and now we're heating that house with that day at 122 degrees. And so forth at 50 degrees. Now we're heating the house at 95 degree boiler water temperature. My heating curve set in my house is about 0.5 for some of my radiant. So if you follow that over, you can kind of see what temperatures I am using to heat my house. Just remember, I am doing constant circulation through radiant. For this example, so our temperature ranges are anywhere from 70 to 140 degree water temperature. So now you can kind of see how you can get that savings to modulating through your heating curve. But just make sure you're gonna kind of get it on the coldest day of the year, whatever your coldest day of the year is. Make sure you set it to what their comfort needs are. So normally, I would tell the homeowner I might have to come out here a couple of times to readjust your heating curve to your comfort level, or some homeowners want to do it themselves. And some of them actually know these boilers better than I do. They're pretty amazing, some people. And I have one customer, she's a lady, and she can talk all about this boiler, and I'm amazed every time I hear her say, well, I did this and this, and I'm like, I didn't know it did that. So it's pretty cool. So just for an example here, I put up a heating curve of 1.6. That's usually where you're gonna do, say you want higher temperatures, 180. So now you can see 1.6 is gonna bring you closer to that 180. I just kind of took the lines out so you can kind of see what you, without the lines in the way, on those different, same temperatures that we had outdoor before. Now with just a heating, different slope. Now you can see on -4 that day, now we're gonna go to the maximum of the boiler. Rest of the time, do we need that temperature? No, most likely not. So when I started doing the constant circulation, or not quite constant circulation, through baseboard, the calls I started getting was my heat's not working. And I'm like, what? And they're like, no, because I can't smell it anymore. I don't smell my baseboard working anymore. I'm like, oh, you don't smell the crayons and the hair burning anymore. And I had to explain to him, what's your thermostat reading? Well, it's set to 70 and it's 70. I'm like, well, we're just heating with lower temperatures. So it's an education for the homeowners as well. So just to be aware that you're telling them that it's going to take a little while to get accustomed to it, noise-wise, as well as you'll see how you're comfortable. Yeah, and a lot of them find it to be a lot more comfortable as well. And the way I used to do it was they could still have their thermostat. I just wouldn't bring the end switch over to the boiler, so it would shut their pumps off if it ever hit that 72 where I would put it, but I would put the boiler room temperature set point at 70. So we would never hit that. So the thermostats basically became high limits. So I could get longer runs through the boiler and more comfort levels with the baseboard. So this is right out of the manual itself as well. And this is just showing you your different emitters on the left-hand side. And A, B, and C is just telling you, explaining you what kind of emitters they are. So with the A is normally going to be your radiant floor, your in-floor radiant. Medium temperatures could be your Runtal or fan coils. And then high temp could be high output baseboard, single pass fan coils. Excuse me. Then in the on the same page in the manual, it gives you the A, B, and C, and gives you some starting points for your radiant. So A would be anywhere from 0.2 to 0.8. B would be your B, anywhere from 0.8 up to 1.6. And these are starting points. I have done some radiator jobs where I was more down at the lower temperature settings. They hold the heat for a long period of time as well. So it's a good emitter when you're doing like constant circulation, things to that nature. That same menu button at the very bottom with the controls, if you want to change your domestic set point temperature, or here's where you would do your DHW time program or your DHW recirculation time program. Remember, if you click on your DHW time program and you it will say automatic and individual. If you are doing a heating time program and you leave it in automatic, it will automatically follow the time program that you have for your heating. If you want to just do an individual time program just for your domestic, you can do that and just do it individual. And so you would click individual, the time program would come up, and then you just set the times you want it to come on and off throughout the day. If you were doing solar and you had a solar control connected to the boiler, you would see a sub menu for your solar as well. So remember, that's auto recognized as well. Mixing valves are auto recognized, so you would see all of that as well. The temperature set points for your mixing valves. Test mode, that's if, say you want to get to the job, you want to see if the boiler fires, or before you leave, you want to see the boiler fire and your pump come on. That's your test mode. What that really is for, in Europe, they have people that do the efficiency through the chimney, and they come in, you have to push that button so they can go up there and do the efficiency test. If they find that it's not meeting efficiency, they give you a certain amount of period to fix the problem, and if not, they come and take your boiler away. I know that'd be nice here, right? I'm still working on old boilers from 1800s, believe it or not, that were converted from coal to oil. So once we click on that, what we'll see is it'll allow you to adjust your domestic set point. It'll come up on the screen. If you're doing zone circuits, it'll be a little different. But you'll just go up and down with your up and down arrow to adjust your temperature here. If you're going above, I think it's 118 here in Massachusetts, anti-scald valve is recommended, or code actually. And if you're doing your domestic, this is just showing you what the screen would look like for your domestic time program or recirculation program. The information button, excuse me, that's just to see what the different circuits are doing, or your, and if you hit the general button itself, the submenu will come up here, and it will give you your outdoor temperature, your boiler temperature, your run hours, things to that nature. Talk about the startup wizard a little bit here. So now this is the way you would get the boiler now today. So all that stuff I was showing you was when this boiler first came out. Now, when you start up the boil, the initial power up bar still comes up, so you see it power up. Next, first thing it's going to ask you is, do you want it in American English? You're just going to hit OK. Set your time and date. Remember the importance of your time and date. And then at the same time, let's set your Fahrenheit and hit OK. If you're doing domestic and you plugged in the number 5, it will ask you to set up your domestic set point as well. So you don't even have to go into settings and do this. It'll come up automatically. If you're not doing domestic, it will bypass this product portion of it and go right to the next part of it. Next part, what we're looking at here, if you're doing the older way of heating circuits, you're going to click no zone circuits, and it's going to give you heating circuits. So say you're controlling 2 of our mixing valves, you're going to have heating circuits. Remember, they have their own pump, so you're just going to control the heating curves for those. So you're going to go in here and set up heating circuit 1, 2, or 3. If you're doing zone circuits and you pushed 1, 2, or 3 zone circuits, this would be the screen that would come up. So you would go from here to this style screen. This is more of the startup wizard feature that's on this boiler here. So this is where it's going to take those end switches and thermostats. You can still see here we're set up for what the boiler temperature is, but it's still set up for outdoor temperature here. If you're doing a fixed set point, you will not see your outdoor temperature. We'll talk about that a little bit. So we're going to just go over and just show you an example. So when you first start up the boiler, for this one here, we're going to pick 2 zone circuits for an example. For the first example, as you can see, as soon as we pick 2 zone circuits, we hit OK. The next thing it's going to ask you, do you want to do a fixed set point or do you want to do a weather compensating with heating curves? For this example here, for zone circuit 1, we're going to pick a fixed set point. Hit OK. Next thing it's going to ask you is set your fixed set point. And this is pretty much where you're set to when you get the boiler. So when you get the boiler, you want to make sure if you want to hit those fixed set points, you're going to come here and put whatever temperature you want. If you want the 180 out of the boiler, you're going to hit your up arrow, make that 180, hit OK. Next thing it's going to ask you is, do you want to use a pump output? Remember those pumps I show you at the bottom where we're going to wire those in, the 2820 or the 157. Remember, we got to power that 157 output. So for this example, we'll pick the 2820 output for the fixed set point. Click OK. That heating circuit 1 is now done. Now we're going to do zone circuit 2. For this example here, we're going to pick weather compensated. Next question it asked, excuse me, set up your heating curve. Remember, we're defaulted at the 1.4. So if you want hotter temperatures at your coldest day of the year, you're going to adjust that 1.4 up. And don't forget about your 0 Kelvin if you want to make any type of shift at the bottom end of your scale. You can also reduce that bottom end of the scale. So say you're getting solar gain at your lower temperatures, you can lower that down at your lower end of your scale so it will go off sooner. For this example here, for the heating curve zone circuit 2, we're going to pick out pump 157. If you added an AM1 module to the boiler, or an AM, or if you added 2 AM1 modules, you would now see an AM1 module output come up here, and then AM module A2 output come here. So they just added 4 more pumps to this boiler. So you can set up another heating curve, another fixed set point, another heating curve, fixed set point. So this is just a very quick video on how to here. And this is more from our tech support very helpful guy from tech support. He helps us also in the academy.
Start by selecting your desired language. Next, set the time and date. The time is in the 24-hour format. The date is a month, day, year format. The next step is to select your temperature unit. For this example, we will select Fahrenheit. At the zone circuit settings screen, select the number of zone circuits you will be connecting to your boiler. For this example, we will be selecting 2 zone circuits. For zone circuit 1, we will select a fixed set point setting. Under the temperature set point screen, set your target temperature. Under the output configuration screen, select the desired pump output for the zone circuit. For zone circuit 2, we will select weather compensated functionality. Under the heating curve screen, make the necessary adjustments to the slope and shift to achieve the desired heating curve. Next, you can select the desired pump output for the zone circuit. The zone circuit settings screen summarizes your selections. Continue with OK, and the startup is now complete.
So you can see it's pretty quick and easy to start up this boiler. The neat thing, the new boilers coming out, I had the luxury of being part of some questions that they had actually. And the new thing is that when you go to order these boilers, if you know the size of the house, the bedrooms, the bathrooms and all of that, you give that to your supply house. They will give you a startup card that will set up this boiler automatically. So the new boilers, you can do all off your phone. So I'm pretty excited on the new things coming out within the near future here. So we're about the halfway point for the programming, basic programming under the control.
All right. Looks like there are no questions, Jay. Feel free to carry on.
All right, guys. You're not sleeping on me, right? Not playing video games, just playing around. Here we go. So now we're looking at that interface and showing you, we're looking at zone circuit 2. Remember, we set that up for weather compensation. So let's look at these, what we're looking at here. Excuse me. So what it's showing you here on the main screen is that we are looking at zone circuit 2. If you pushed your left or right arrow, this would bring it to zone circuit 1, zone circuit 2, or if you had zone circuit 3, you could push that arrow left or right and just keep changing your screen that way. But as you can see, we're running, so that represents a radiator, excuse me, a radiator. So we're in the heat mode, and then that circle with the triangle in it here, meaning that our pump is on. Right below that, we're looking at our outdoor temperature. And then over here, we're looking at our current boiler water temperature. Next one, now you can see zone circuit 2. I'm sorry, zone circuit 1. Now you can see that the radiator's on. We do have our pump is on, but now you don't see the outdoor temperature. Remember in the prior screen here, we had the current outdoor temperature. So we're doing weather compensation here. So we're looking at our outdoor temperature. Whereas this one here, we're doing a fixed set point. If you hit the zone circuits, you could see what they're doing and how they're set up that way. And then under information, you could see what they're doing, actual set points. On the HC circuit screen, this is what you're looking at. So at the very top, you'll see that it's domestic and heating mode, or if you were doing just domestic, you would see the faucet up at the top and no radiator. With the startup wizard, you'll see that it will, once you're done, it will automatically put it in the standby mode. Where if you put it in a standby mode on heating circuit 1, you might not have heat. Heating circuits are different than zone circuits. With zone circuits, the newer way, I call it newer, but it's not really new. If you see it's in standby mode, you're fine, because with the zone circuits, we're waiting for an end switch to make that contact. And then if it goes into domestic, the sensor takes over and tells it to go into domestic. So that's why it puts it in standby on the zone circuits. This is just showing you how to set multiple heating curves, what they would look like if you set a 1.6 heating curve, or a 1.2 heating curve, or a 0.6 heating curve. You just can see the different temperatures while you're looking at the different heating curves. That's what I liked about this boiler here, is that we can see the actual temperatures that we're setting our curves to, and not just setting it to a baseboard type of slope or whatever. To access the service menu, I find this is very helpful one to know here, because here you can see all your actuals, set points, your fault history, and service functions. So let's talk about that a little bit. So all we're going to do is press OK in the menu key, both these buttons here, OK and menu, for both at the same time for about 5 seconds. You'll then see the screen come up, and then it will say service at the very top. You'll find that most of your coding levels are done in coding level. Coding changes are done in coding level 2. Here's where you'll be able to see your fault history, service functions, and then end services, just to get out of the screen. So when we push these buttons here, so we hit the service button, so service menu here, service functions, service menu. We can now see the different things that we can see here. So if we go into diagnosis, diagnosis is a good, helpful tool. You can see all your actuals, your set points, your outdoor temperature, actual and dampen. Is my pumps on? Things to that. So it's a good way to see how everything's working. The actuator test is a really neat thing as well. So you can go in there and do, this is where you would do your high and low fire test through actuator test. I'll have a sub menu come up here shortly. Service functions. As you can see, the sub menu to the right hand side, as soon as you press that one there, you have a sub menu that comes up. It says participant check, service pin, service reset, filling and venting. This stuff will disappear if you're doing multiple boilers. Participant check is kind of when you're checking, tying into other boilers, and you want to see if you're communicating to each other. I like to talk about the filling and venting mode, because a lot of guys don't know that's here. That filling mode is when you're first initially filling the boiler with water. It exercises the pump to help you push the water through the coil of the boiler. So the pump comes on for a longer period of time to help push that air through the coil of the boiler itself. The venting mode is once you've done the fill and you got it pretty much filled. Venting is what I call, or what we call here, purge mode. And what I normally do is I put in that there, and then just on the left-hand side, I have an isolation valve underneath that boiler drain that we give you. I shut that and then just open up the boiler drain with a hose and then purge out the rest of the air in the system. It works really well. Maximum output, what that is there is, say you get to the job and it's going to high fire, but it's snuffing out. Could be your gas screen is dirty, or so your gas piping is too small. So what you could do there is just your maximum output of your heating. You can reduce that there, and we'll keep it running until you can get out there and either upgrade your gas piping or figure out what's going, or why you're not getting enough gas to the boiler. Multiple boiler system, that's where you're going to go in there and click OK on that. And that's if you're doing multiple boilers, because you can do up to 8 boilers on a cascade system with these 200s here. Cascade 8 and common vent 4. And use one cascade control to run all the boilers. There would reboot and go into a multi-boiler setup on the screen. That's a different class. The neat thing with the fault history, it does give you the last top 10 faults. Number 1 being your newest fault, number 10 being your oldest. If a new fault comes in, number 10 drops out, number 1 gets replaced with the newest fault. Lastly, if you start up the startup wizard and you find that you made a mistake, if you go into that service function, you go down to the very bottom, it says reset the wizard. As soon as you click OK on that, it's right back to set English. It's that quick. And so if you made a mistake on your heating curves and you don't want to go back through and go into settings and find heating curves or whatever, you can go right here and do reset the wizard and start right from the beginning again. Actuator test, this is what I find pretty neat for relay test as well as troubleshooting. So when you click OK on the actuator test, it comes up with all actuators off. So none of these would be on when you first click on this. It will say off all the way down. As soon as you hit the down arrow and it highlights the base load, it automatically turns it into base load, puts it in low fire. So that's where you're going to go when you initially start this boiler, do service on this boiler. You're going to go into base load and do a high fire and check your COs and your O2 levels on this base load. As well as we want you to do a high fire test as well to make sure that your CO2s and your O2s are in the accurate areas. Just remember with this boiler, there is no gas valve adjustments on this boiler because we have that beautiful Lambda Pro on our Lambda Pro technology in this boiler here, meaning that it will automatically set up almost to perfect combustion every time it fires. And that goes through its cycle on its first initial, and then it goes like every 2, every 4, every 8, until it hits about 230 cycles, and then it starts Lambda Pro over again. Unless you go there, you push the on and off button, it will recycle and start your Lambda Pro. The reason why I say that is if you're doing any type of efficiency test, and you first push on that boiler, do not have your analyzer in the boiler for about the first 88 seconds of operation. Because with Lambda Pro, when it first initially starts, it first checks itself at really lean, meaning now we're giving it way too much air than it needs. And it checks its flame sensor reading there. Goes to what they call Lambda, which is perfect combustion, checks itself there, and then goes to really rich, meaning now we're giving not enough air to the boiler, and it checks itself there with its flame sensor reading. Then once it does that, it goes back to Lambda, or a little 1.3 of excess air. Then it's good for you to put your analyzer in the boiler, because if you do it when it's going through a really rich, your analyzer is going to go through the roof. So if you're doing that, just remember that during your full load and on your base load, make sure that it's already up and running before you throw your analyzer in there. So if you want to check that 20 pump output, remember that's your pump output that's going underneath your boiler, pumping into your boiler. You can, each time you hit the down arrow and then it comes up to that 20 pump output, you click OK on that, and then you can go down to the relay, that 20 pump output where you tied your 20 pumps, see if there's power there. If there's power there, then we know that there's something wrong with maybe our circulator, could be jammed or could have died out. So it's just a nice, easy troubleshooting thing. If you do have our mixing valves tied to the boiler, you can go here, open and close them, put them in the center position to make sure that you wired them correctly, because these are powered open, powered closed mixing valves. So if you got them wired wrong and you come to your actuator test and you see it's closing instead of opening, all you have to do is reverse your wires. You reverse your wires, you're good to go. You go check here. If you don't have any of the stuff plugged into the boiler, you're not going to see any of that stuff. for your actuator test. So basically you might see 3 or 4 things. If you have your 2820, you might see that as well. But if you don't have any of that stuff plugged into your boiler or plugged in, you're not going to have to, you won't be able to see any testing for it. To get into coding level 2, once you pressed OK in the menu button at the bottom, then you're going to press OK in the return menu at the very top for another 5 seconds. That will now put you into coding level 2. Once you get into coding level 2, you now can see all your different coding levels of the boilers itself. Generally, you're going to find you're going to do coding there as well as boiler. And remember that DHW 5B, if you're on the other side of your domestic, this is where you would go. I'm sorry, on the other side of your low loss header, this is where you would go to make that change, 5B under domestic. If you clicked OK on general, these are your ones that would come up here. Your 00 is your system type. So I always like to talk about your system type. So remember, everything's auto recognized. So I can tell right here that my domestic on 00 is not tied in. Reason why I say that, because I know when domestic's tied into this boiler, I always have an even number on that 00. So if I had a 2 here, I know I would have domestic tied into this boiler here. So if you look at our chart, and I'm pretty sure I'll have that come up here in a second. 00 is what type of system. So on this one here, I know I have one high temp system, and that's all I have on this boiler. If I had a 2 here, I would say that I would have one high temp system with domestic. As soon as you plug your low loss header sensor in, that would automatically change. But say you put it in and you don't want it in there, you would have to come into general here and make sure you put 52 to a 0. When you're changing your gas coding from natural gas to propane, there is a coding that you have to go into address 11. The password for that address 11 is 9. Once you hit OK, you'll see you hit OK with 11. The 0 now comes highlighted. You hit your up arrow till 9 comes in there. And that will allow you to go to address 82. So it's kind of like a lot. So the homeowners will now go up to 82 and just change it from propane to from natural gas to propane by messing it up. So it's a kind of a safety on there. So the other thing too is a lot of times when you put that 9 in there, I used to get the phone call. I put the 9 in there, but it's switched back to a 0 here. It's going to do that. It's going to switch back to a 0. But what you're going to see, that code 2 at the very top here is going to come out of the picture, and you're going to see like a skeleton key come up here. So now you know that you opened up unlock the door. So now you can go to address 82 to make that change from 0 to 1. Once you put the 1 here and you turn the little dial on the gas valve itself from 0 to 1, you now have converted your boiler over to propane. If you're in the higher altitudes above 10,000 feet, there's actually a coding card change, as well as you can adjust your altitude here. A lot of times that's not recommended. I would talk to tech support if you're having issues above and beyond coding card changes, because sometimes we found in some altitudes above 10,000 feet, didn't really need the coding card. It's a fan speed change because the air is lighter, but sometimes we find it ran better without the coding card. So you'll see changes to that coming up as well. Still in your general coding outputs here, 53, you can go in there and change the outputs of your pumps. 36 as well, that's for your 157 output. 53 code is going to change your 2028 output. And then code 39, if you wanted to go in there without starting the startup wizard again, you can go in there and make the changes to whatever type of pump you want it to be. If you were doing external demands on the older way with HC1, HC2, and H3 on DE1, DE2, unlike the zone circuits, these are, I'm talking heating circuits, you actually had to go into coding and make the changes to tell it what you wanted to do. And then what temperature would be. 9B is your temperature change. So with the heating circuits, you could only have one fixed temperature, and that was by changing 9B. So if you had 3 different HC1, HC2, HC3, they're still following that same temperature output here. That's the nice thing about zone circuits. So they really made changes to this boiler over the years to more help here in the US. When I first started installing these boilers, the maximum temperature was 167. Would not go over that. So I had to become pretty creative with a lot of jobs here in New England that were designed for 180. If you did choose the boiler mode there, this is where boiler and coating level 2, remember how we had general, now boiler. So you go into coating level 2 and now clicked OK on boiler. This is where you can put your service intervals. You can do it in hours. You can do it in months. You can have it display a wrench or no wrench. Excuse me. What that means is you're allowing your boiler to tell you that it's time for the annual maintenance or annual service. It will put a wrench on the screen. So what that service display is, do I want a service display so Mrs. Jones can see that it's now time for my annual maintenance or not? Because we know that some homeowners, if they see a wrench on their screen and it's time for their maintenance, they're going to get right on the phone and demand their annual maintenance immediately. So that's up to you. Some customers are good. They know that you don't have to run out there right away to do the maintenance because it seems to be a lower priority today for maintenance to get everything done. It's just tough with the amount of help and work that's out there today. And remember the, excuse me, the 2F at the bottom here, that's that fill mode. So you can go there as well. But I would go right into the service menu and not even go into coding because you can go right down to that service function and go right to that fill mode or vent mode. So you don't have to go into coding. And then on address 38, I always like to tell guys, so the guys that are doing troubleshooting on this boiler here, if you go to address 38 under boiler, there should always be a 0 there. If you look at the last page of your fault codes on this boiler here, they give you 5 more fault codes that do not display. Excuse me. So if you go to address 38 and you had a 3 here, this is one of our boilers that doesn't give you a fault for a flow. So if you go to address 38 and you see a 3 here, you now know you have a flow issue to this boiler, whether your pump's working, not working, your flow switch is not working. So I like to point that out because that is a little bit of troubleshooting. If you look at that last page of your fault code, it really doesn't tell you what those faults and where to find them. So that's why I always point this out here. Again, as I was talking about here, remember, if you go now, we skipped by general, we went by boiler, now we're at DHW programming. Here's that 5B I've been talking about, primary side or secondary side. So you go to that 5B and it's set for the primary side. So if you're on the other side of your low loss header, you'd go here, hit OK until 0 is highlighted, hit your up arrow, put the 1 in there, and then you're good to go. It will operate correctly. Your maximum temperature of your DHW, you can set that and change that as well. You're not going to go over, I don't think, on this boiler here. I think it's 150 is your max temperature on this for DHW. And here again, if you do have your outdoor temperature sensor, this is what frost protection will do. It will put a snowflake here up here on the screen that looks like this here. So once it hits 34 degrees outside, you now know that the boiler will be maintained at 68 degrees. So say your pump fails going out to your system, the boiler will still be maintaining 68 degrees. Say the homeowner calls, I don't have anything running, but my boiler's still running. This is why. It means that it's protecting your boiler from freezing. Once your temperature reaches 37 outside, it comes inactive. So we're above freezing. It now knows that, and you can actually make changes to that in coding level 2 and boiler. No outdoor sensor means no frost protection, no boiler protection, no outdoor shut off, cold weather shutdown. So this is the MW2C. This is your cascade control for the multiple boiler setup. We sell a rack system with 3 or 2 boiler setups. And like I said, you could have up to 8 boilers on a rack system. This cascade control will control all 8 boilers. The cascade has been changed. This is, as you can see, is the same exact control that was on the front of the boiler. This has been changed a few years now. Just note, it is now a touchscreen on this part here, which I just set up the other day in our boiler room. So I actually was given a class on how to set up multiple boilers with the cascade control, lawn communication, and all of that. So if you're looking to do that, I have that as well. But that means you would remember in that service functions, we saw that multiple boiler setup. If you're going to do multiple boilers, first you have to set up the boilers to put it in multiple boiler system. So you would go into that service function, click OK, put the check mark in that box. You'll see the boiler reboot, and now come up with a totally different screen for multiple boiler setups. So it does have a startup wizard as well. You'll see it reboot. Come up to this screen here, and then there's a little more programming as well for that. It's a different class, but it's pretty quick and painless as well for setup. As you see, these boilers are getting easier and easier to set up, and with self-auto recognize, it's a pretty easy setup. So now this is just showing you multiple boiler setup here. So everything now, your outdoor sensor, everything would now go to the cascade control, and the cascade control would do all the functionality. You still would need your 20 pump underneath your boilers on your return side to activate that flow switch. But this would now control your BMS as well as your circulators going to systems, your domestic, all your sensors would go up here to your cascade control. So I'm sorry I ran a little longer than I should have here, but hopefully you got some information that you need. I covered pretty much all your screen displays. Remember the importance of the time and date, your fault code history, your time programs, your vacation mode, things to that nature. You can either do a fixed set point or do a weather compensation. So that's your difference between your boiler setups on your startup wizard there. And hopefully you learned a couple of things about your heating curve that might help you down the road as well. So we're kind of at the end of the presentation here. Oops, sorry. Hopefully you all got the information that you came for. And again, I want to thank everybody for coming and spending an hour and a half or so here at, with training here at Viessmann. And remember, we do these quite often. So if you see something else you like, please sign up. If there's something you'd like to see me change or do, please send that in with an email as well. I'm more than happy to help companies out as well. So thank you again for joining us. Hopefully you got your bread and milk, because here we're actually looking at a big storm coming up the East Coast. I always say bread, milk, and oil, because I was an oil technician for a long time. So it was always crack me up when people were saying, I got to go to the store and get bread and milk, but I had to go deliver them 10 gallons of oil in a jerry can. So remember your oil. That being said, thanks everybody for joining, and thanks Miranda for your help today.
Thank you, Jay. Just a few reminders before we close out. This will be recorded and put on the video library within the next 2 weeks or so. So you will be able to go rewatch this if you'd like, or suggest it to your colleagues to watch it. My email is on the screen. Feel free to email me any additional questions. We will send out a Q&A document with all of the answers. And then tomorrow does mark our last one of 2020. So feel free to register for that, or just keep an eye on the email for the upcoming 2021 schedule. And with that being said, that does conclude today. So thank you for attending and have a great rest of your Wednesday.
Thanks, everybody. Have a great day.